Data collection for, I call that data collection for systems design, because in fact, it's a question we have. We are dealing with an activity which is really complex compared to car, which is riding activity. Of course, riders share infrastructure with cars, trucks, but they have specific characteristics. The vehicle dynamics is totally different, conspicuity is totally different. And more than that, that activity is with a high level of risk. The rider, I will not insist on that, we have a strong vulnerability of the rider due particularly to poor conspicuity and poor protection. Yes. But that activity, which is a complex task, is poorly studied up to now. We have some research, of course. We have some projects aiming at observing behavior, but we have very few projects aiming at understanding behavior. It's totally different. Looking at something is not understanding what happened. So, and we have a need for scientific countermeasure in order to mitigate fatalities and injuries. And we cannot design a countermeasure without understanding, in my opinion. Otherwise, it's only, I believe that, so I design that countermeasure, but in fact, at the end, that countermeasure, you have a big risk to have a countermeasure which is not efficient, because that countermeasure will not answer a true question for the riders. Okay. So data collection, what for? So we have different needs, in fact. And we have different needs because we have different purposes. We need data in order, for example, better design road infrastructure. We need to understand why we have accident in curves. Is it in the curve design? And so we need information. We need information about if you want to design equipment. You need also to know information about PTW volume, to have information about average speed, all that. If you want to put equipment on rail guard, for example, you need, of course, you will prioritize and put that equipment on the road which are the more used by PTW. If we are speaking about training, licensing, retraining, one more time, what we need is to understand and to evaluate the system, to try to look at what happened to novices, why they face problems, which problems, in order, on that one, we need data on that in order to potentially change the training licensing scheme. For riding aid devices, design, tuning, and particularly HMI, of course, we need to know the context of riding. What about the road? What about meteorological factors, traffic? It's important to have information about rider skill, and we need data on rider skills, contextual riding style, but also the use of systems if the vehicle is equipped. All that data are very important in order to better tune, design or better tune the systems. For riding support systems, design tuning, one more time, including HMI, it's also very important to have information about the dynamics of the PTW, to have the dynamics of the rider actions, to know the context of riding, road geometry, meteorological factor, one more time, and also the use of the system. And for eCall, which is a little bit different, we need, of course, the dynamics of the PTW and or of the riders, because it could be interesting to have also the dynamics of the riders in case of falls. Of course, we need the localization, we need the use of the system, and so on. So we have different needs for different purposes, but all that we need data. Please. Okay. Just an example, in case of an alert system, the study of an alert system acceptability, it's very important. We have some criteria, and one more time, if you want to design an alert system, and if you want to study the acceptability, you have to take care about the benefit for the driver, simplicity of use, at least non-regression in terms of safety, and what is very important is the reliability of the system, which is the number of false alarm and the detection rate. All that are very important. And for all that, when you design such a system, you need a set of data, as I explained before, and you need to look on road, if possible, on simulator before, but after on road in real situation, if it works or not. Okay, so data collection we need, but now how? How? Alors, you have, in fact, when you collect data, you have two ways. You have what we call, and on simulator it's a case, reproducible situation, also called controlled situation, because you have the control on everything. So it can be either FOT, field operational test, it can be on tracks, it can be on closed roads, it can be on specific itineraries, specifically equipped with ITS system. And on that kind of tools, I will say, you can do either false reproduction using often stuntman. You can achieve a near false reproduction. You will, in that case, you will use stuntman or professional riders, and you will acquire data on what happened in close near misses, but where the rider don't fall at the end. You can reproduce a subset of riding episode. That means, for example, approaching or passing specific difficulties. You arrive on a roundabout, and there are some cars, some vehicle. You arrive in an intersection, and of course, that FOT, for example, in that case, it's very important, and I say ideally, but it's very important to look at it in different countries in order to have different cultures, because as we see in previous talk, the cultural aspect is very important. Riders are different in a country, but riders also are very different between countries. So advantage of that reproducible situation, it's reproducibility that allows easier analysis and that allows statistical modeling, because you can replay many times exactly the same scenario and look at the difference in behavior. I will not speak about limits here. I will only stress the interest of such approach. Another possibility is to use non-reproducible situation. That means also called uncontrolled situation. In that case, you don't give any order to the driver-rider. The rider will use the motorbike exactly in a normal way, commuting in a normal way, using the motorbike for leisure. It's up to him to use the motorbike. And you look at the travel. It's what we call naturalistic riding studies. So, of course, what you can do here, it's only to choose at the beginning the population. You choose your population, you choose, within the population you can select novices, experienced returning, you can choose a subpart of the population which use motorbike for commuting only, or for leisure only, or for both. You can also select the motorbike, the type of vehicle, and you can select the location where the riders use their own motorbike. Because a naturalistic riding study, by definition, the people use their own motorbike. Otherwise, it's not so much naturalistic. The interest of that one is, of course, it's ecologic situations, and you will capture probably unexpected situation for you, because we are not able to imagine all the situation that can happen in a real situation. So you will collect information which are very rich, sometimes unexpected, which is very interesting, because for unsafe situation it's not very common, so it's interesting to get unexpected situation.